Your thermos isn't magic, it's actually doing something far stranger. Heat wants to move, that's not a preference, it's physics. Heat travels from hot objects to cold ones always, relentlessly. The moment you pour boiling coffee into any container, the world begins stealing it away. Without interference, that coffee would be lukewarm in an hour. But a thermos, it keeps working for 8, 10, sometimes 12 hours. How does it refuse what seems inevitable? The answer lies in a gap, not a metaphorical one. A literal empty space measured in millimeters, sandwiched between two walls of glass or metal. That gap is the secret. And to understand why, we need to step back to 1943. March 1943. A German physicist named Reinhold Berger was working at a glassware company in Berlin. He wasn't thinking about coffee. He was thinking about storing liquid oxygen, a fuel so cold it would freeze ordinary containers instantly. He needed something that could hold extreme temperatures without conducting them to the outside world. Berger's solution was elegant. He created a container with two glass walls separated by a vacuum, or nearly so. A vacuum is emptiness. And emptiness, as it turns out, is the best insulator on Earth. Heat travels through three mechanisms: conduction, convection, and radiation. A vacuum stops the first two dead. Conduction is heat moving through matter, through the walls themselves. Convection is heat moving through air or liquid carried by currents. But in a vacuum, there's no matter, there's no air, there's nothing for heat to travel through. It's trapped. Here's what Berger didn't know yet as he assembled his first prototype. He was about to invent something that would outlast his era. The vacuum flask, later called the thermos, would become one of the most reliable devices ever made. And he couldn't have predicted that. But heat still finds a way, it always does. Radiation, the third mechanism, travels through empty space. It's how the sun warms you from 93 million miles away. No air required. So thermoses address this too. The inner and outer glass surfaces are coated with a reflective material, usually silver or aluminum. Radiation bounces off, trapped. The vacuum flask was patented and licensed. Companies began manufacturing them. One Scottish businessman named James Dewar had already patented a similar design, so the product took his name in some regions. But the brand that stuck, the one everyone uses today, came from a German marketing department. They called it Thermos, Greek for hot. By the 1950s, every camping trip, every Arctic expedition, every long drive relied on the same principle Berger discovered. The vacuum between walls, the reflective coating. Simple, brilliant, unchanged. Now the vacuum isn't perfect. It's never absolute. A few air molecules remain, especially near the seal. But that's actually fine. It's fine enough. The insulation is so effective that heat loss slows to a crawl. Here's the math. A thermos can lose only about 1 or 2 degrees Fahrenheit per hour. That's why your coffee stays hot for hours, why ice water stays cold. The gap between the walls does the work. You pour in heat or cold, seal it away, and time slows down. But there's a catch. The seal matters. The cap is where heat escapes most. Open a thermos and you've broken the system. You've let convection back in. Air currents form around the opening, heat rises and leaves. Modern thermoses have improved the design. Better seals, stainless steel instead of glass, lighter, more durable, but the principle remains untouched. A vacuum, a reflective coating, that's it. That's the entire magic. What makes this remarkable is its simplicity. We live in an age of complexity, smart devices, algorithms, apps that learn. Yet one of the most reliable, most useful objects in your home is based on a principle discovered in 1943. Empty space insulates better than anything else. It's a reminder that solving a problem doesn't require complexity. Sometimes it requires the opposite: nothingness, absence, a gap between two walls, and that gap has kept billions of cups of coffee warm one morning at a time for 80 years. The next time you unscrew a thermos cap and feel that warmth still there, remember, you're holding physics. You're holding a vacuum. You're holding the everyday magic of emptiness doing work. Subscribe to uncover the hidden physics in the ordinary objects you use every day. There's a new discovery waiting in your kitchen.